Hey there! In this video, we're going to address an interesting problem related to struct sizes. Have you ever wondered why the size of a struct changes when endianness is specified, even when it matches the native endianness of the platform? Let's dive into this issue and understand why this extra padding occurs. When dealing with struct sizes, it's crucial to consider the byte ordering. If it's not explicitly specified, it defaults to at, which represents the native size and alignment. This alignment ensures that data types are positioned correctly in memory for efficient access. In the case of BI struct format, the unsigned integer, I, takes up 32 bits, while the unsigned char, B, only takes 8 bits. As a result, the integer needs to be aligned on a 32-bit boundary, leading to the addition of padding. This explains why specifying endianness can impact the overall size of the struct. *** solution. *** to avoid unexpected changes in struct sizes, it's essential to be mindful of byte ordering. By specifying the appropriate endianness, you can control how data is arranged within the struct. Remember that alignment plays a crucial role in determining the size of the packed byte object. In this case, specifying endianness helps ensure that the struct is packed efficiently without unnecessary padding. In summary, understanding the impact of endianness on struct sizes is key to managing memory efficiently. By being aware of how byte ordering affects alignment, you can prevent unexpected padding in your packed byte objects. We hope this explanation has shed some light on this intriguing problem. Thanks for watching, and remember to subscribe, like, and comment below with your thoughts. See you in the next video.